Hello everybody and welcome to this video where we will be solving questions about electrical fields. So let's start with this first question. Question number 1, it says, which is the correct statement about the electrical force on a positive point charge added between two charge plates at the locations 1, 2, 3, and 4. So we have a positive point charge that is located between two plates, okay? So it says here that the force is the same at all points. The force at 2 is the largest, the force 3 is the largest, and the option number 4 is that we need more information. Well, actually, what can help us here, if we draw the electrical field, we know that the electrical field between two plates is going to be a line that is leaving from the positive charge going into the negative charge, like this, right? And we looked at this one before and called it a uniform electrical field. And if we have a uniform electrical field, we know that the electrical field will be the same at any point between these plates. So if the electrical field is the same at any point between the two plates, this means that the electrical force will also be the same at any point between the two plates. So the correct answer is A. Question number 2, which of the below images indicate the following? First one is, which picture A, B, C, or D gives us or shows us the electrical field between two similar charges? Well, A is a uniform field, we know that. B is showing me a certain shape. B is showing me another shape where we can see that we have A, B, C, and D. Well, we've seen these shapes before, and it's very easy and obvious to say that the electrical field between similar charges is going to be C. Why is that? Because we can see that the electrical fields, or they are not going from one of the particles into the other one. This means that they both have the same charge. A uniform electric field, it's obvious, it's A. Now, an electrical field between a large charge and a small charge, we've seen this before, so it's obviously B. And finally, the electrical field for a negative charge, we can see that the lines are going inside or towards the particle, so this means that it has a negative charge, so the answer here is D. So we kind of have to memorize the shapes for different types of electrical fields. An object has a charge of 4 microcoulombs. What is the strength of its electrical field 20 centimeters away from the charge? So let's try to solve this one here. Imagine that this is the charge. It's a positive charge, it has a charge of 5 microcoulombs, and this is where we want to find the electrical field. We know that the electrical field goes in all directions equally for a positive charge, and it's leaving the charge, as we can see here. So the distance between the charge and the object is 20 centimeters. Let's remember to transform it into meters so we don't forget that. So it's equal to 0.2 meters. We know that the electrical field is equal to Coulomb's constant multiplied by the charge divided by the distance squared. So it's pretty straightforward. Coulomb's constant is 9 multiplied by 10 to the power 9 multiplied by the charge. The charge is 4 microcoulombs, so that's 10 to the power negative 6. And then we will divide it by the distance. The distance is 0.2 squared, okay? So that will give us the answer of 9 multiplied by 10 to the power 5, and the unit is Newton per coulomb. So let's see what choices we have. As we can see directly that our answer is right here, B. Question number 3 and last question. The image below of an electrical field created between 2 points indicates that A, the two charges are equal in magnitude, opposite in charge. Equal in magnitude have the same charge. Unequal in magnitude, opposite in charge. Unequal in magnitude have the same charge. Well, first of all, we know that since the lines of the electrical field are leaving from one particle and going towards the other particle, this means that they have to have different charges. And this must be negative and this must be a positive charge. So we can say that this It can be either this one, the opposite charge, or this one because it has opposite charges. You do not have the same charge. Okay, so are they equal in magnitude or unequal in magnitude? Because we saw the shape of the electrical field, if we had equal and unequal magnitudes of charges, this makes it clear and obvious that these charges are opposite in charge and equal in magnitude. As we can see here, equal in magnitude and opposite in charge. That was pretty easy and pretty straightforward. Stay tuned for the next videos where we will be introducing new topics related to electricity. See you then.